Okay, let's look at this question number 3, because last time we were running out of time to explain this one. So let me just focus on this one question here. If a right triangle has legs 6 and 8, and its hypotenuse is like hypotenuse is 10, right? The triangle will be inscribed within the circle of the area of 25 pi. Hypotenuse will be the diameter of the circle. Suppose one leg of triangle is known to be exactly 6, but the other leg is known to be 8 with the area of positive and negative edge. What are x, fx, and a for this problem? This is like this here. The story is this. We have a circle. Okay, we have a circle. And then they told you that this area of this circle should be what? 25 pi. So we know that area of the triangle equals what? Pi r squared, right? So that means r is 5 here. So the diameter will be 10. So, and make it bigger. Okay? So, if that happens, so we have what? A circle like this, right? And then this is 10 supposed to be. And then inscribe the triangle here. And be careful, because this is diameter. So from geometry, if the triangle, this angle face a diameter, this angle must be 90 degrees, okay? And right now they said what? They said we give this side of the triangle is 6, fixed. But this side is changing from the 8 and add by or minus by h. H's keep changing. And we can assume this one equals x first. So that means this side is keep changing, okay? So that's why the x, we can set it as what? 8 plus h, right? Or minus h, keeps changing. And then the fx will be the what? The area of the circle, okay? This area of circle. And then the a, we can consider as the constant as the 8. A will be the 8. So it means starting from the 8, the size keeps changing, okay? That's this about, all right? This was just said with based on this lesson, they put it this way. Make the question simpler. 8 is 8, means a fixed number of the side. From there, this 8, the leg of the right triangle will be changing, maybe add by h, minus h, up and down changing. So we set this overall as an x. And then fx is the area of the circle. And when you do the C there for this question number 3, when you do the C there, the fx will be what? The volume of the sphere, okay? Now, if you have this, the first step we can find out is this. We can say f of the x equals to pi r squared, right? So this one we call as r. And this one also is r. So that means the diameter is 2r here right now, right? So if we have that, we can represent the area of the triangle as what? As the function of x, okay? We need to represent that. How do you do that? We use geometry, huh? Geometry, we have Pythagorean theorem there. We said what? 6 squared plus x squared will be equals to r squared, right? No, 2r squared. 2r is a Pythagoras. This is diameter. This is the hypotenuse also. So from there, we can get what? 36 plus x squared equals to 4r squared. And then we can find r squared now. R squared will be equals to x squared plus 36 divided by 4. This one. Okay? We're going to plug this one back to here. So we will find out the fx will be equals to pi r squared. R squared equals x squared plus 36 divided by 4. Okay? So we got this now. And after we got this, they ask for what? When you do the B, look at what they ask for B, okay? When we do B here, they ask for use the tangent line approximation to estimate the area of the circumscribed circle. So they're asking you to find out the approximation of the area of the circle because the edge is changing, means x keeps changing, okay? How do you do that? For this one, for when we do the A, we already find out what? We already find out x is this one, right? And then we find out the A is 8. And then we find the edge, fx is this. We find the A already. We finished A already. Now we go to the B now. The B here, they said what? You need to find out approximation. This part is related to, we call it as a linear approximation. Means generally to find out the value of the function, because this x is keep changing, it's 8 plus h, right? So what I'm gonna do is this. We try to use a straight line to do the approximation, okay? Let me give you the graph to see this one, what they're talking about, okay? I put the graph here. For example, this is the function, okay? So make it more close to the original one because we know this one is what? Open up, right? So for example, I just say whatever like this, okay? Now, suppose this is the x, this is the fx. Let me explain what's this question about, okay? So make sure you know how to use the linear approximation to do this question. For example, this place is 8. So we know if this is the 8, this area will be what? If this is this side is 8, right? And this is 6. Pythagoras, this is 10, right? So that's the time the area of the circle equals what? Pi times by what? 5 squared, right? So that's why you have 25 pi like this, right? That's why they said this is 25 pi, huh? But that's a fixed number. But right now, they said what? Somewhere here, this place is 8 plus h. Or somewhere here, this is what? 8 minus h, like that. So the area is not the original one, 25 pi anymore, right? I try to make it a big exaggerate, okay? So easier for you to see. Let me erase this one first. So make the graph is like steeper here. So you can see that from here, they go like this, okay? Like this. So when this one is 8, this is 25 pi, no problem. And when the x 8 plus h here is 8 plus h. That's this one. This height. This is the area of the circle, right? But generally, we need to what? We use, you need to find out, actually you need to find what? You need to find the F8 plus H, right? But that's more complicated. So they ask you this, for this question B here, they ask you what? To find the tangent approximation. Means they ask you to find how long this one as the approximation, because here, this point here is what? 8 and F8 plus H. That's this point. So you're looking for 8 plus F8 plus H. But they said here, no, that's too complicated. You just simply find out what the linear tangent approximation means. You just need to find this one. Okay? How do you find that? Let me show you how. Okay? Here. We go this point. Right? We go this point now here. So this one we can go as what? This is the 8, right? And this one is what? Y, like this. Right? I'm using this Y right now. So how do you do that? We go like this. We use the approximation. So we can go, we have this point. This point here is what? This point here is 8 and F8, right? Like this, huh? So we can say, generally, original one is the slope. We can get the slope of the second line here. So a second line is what? F, this is Fx, huh? So we put it as F, or we put it as a Fx minus F8. Because originally it's supposed to second line here, right? This point is 8, F8 plus H. 8 plus or minus H is X. So Fx, this is Y2 minus Y1. Y1 here is F8 over X2. That's X. That's this point here. Because this point we consider as X. Okay? X minus what? X1. X1 is 8 here. This one's supposed to be the slope of second line. But here we do what? We do the approximation. We assume that equals the slope of the tangent line. When you find the slope of tangent line, that will be what? The function derivative at x equals 8. Okay, this is the main idea about the linear approximation. One more time. Supposed to be, you have this point, you have this point. This point is considered as what? 8. This point is 8 and F8. And this point here is 8. Actually, this is the X. This one should be the X. Okay? So this one is the X. Means X plus H or minus H. This is the X. And then the function will be Fx, like this point. So you use this point, you do the, find the slope. So Y2, that's this one, that's Fx, minus F1, that's 8, F8. And over the X2, which is this point, that's X, minus the X coordinate of this point is 8. Supposed to be slope of the second line, but we use what? The approximation of the tangent line to substitute the second line, okay? So we got this one now. If we got this, we can find the Fx right now. We time both sides by x minus 8. So we will have fx minus f8 will be equals to f derivative of the 8 times by what? X minus 8, like this, right? And then we add this on this side, so we can get what? Fx. We're looking for fx right now, but just be careful here. It's not exactly equal, it's approximately equal, right? Because you use, here's, if it's exactly equal, this one should be what? Slope of secant line. But right now, we're using the slope of tangent line. So this one will be equals to, approximately equals to, okay? F derivative of the 8 times by x minus 8 and the plus f8. Now, we can plug in what we're given right now, okay? So fx will be equals to derivative of the 8. We do derivative of this one first, eh? We do derivative here. So f derivative equals what? The pi over 4 is the constant, we leave aside. And then we do derivative of this part. This part will be 2x. So we will find out this one cancel. So a pi over 2x. This is derivative. But here, this one is a derivative 1x equals 8. So that means what? You have a pi over 2 times by this one 8 plug in here. So this times 8, right? And times by this x minus 8 plus f8 from here. So we can use the calculator to do this calculation now here. We do we do the substitution here. We make the 8, right? We put it here, 8 is here. So you're gonna have 8 squared plus 36, you got this 100. And then we divide it by 4. So we got what? 25. So here we have what? 25 pi, like this. Now, we can further simplify. After further simplify this, fx will be equals to, this is 4 pi, and times the x, and the minus, this is 4 pi times negative 8 is 32 pi minus, right? And the plus 25 pi. Got it? And then we can simplify a little bit more. So we have what? Fx will be equals to 4 pi x, right? And then minus 7 pi. Now, if you want to put the answer in the form of what? In the form of the edge, what we're going to do is this. We simply substitute x equals what? X equals 8 plus minus h. We substitute here. We will get the answer is 4 pi. X is 8 plus or minus h, and then minus 7 pi. And continue. Continue, we will get here. We will get this one times this one. We got a what? 32 pi plus 4 pi h and a minus 7 pi, right? Oh, 4 pi h, but you have a positive negative, okay? And then the final answer will be positive or negative 4 pi h and plus 25 pi. This equals fx. Of course, approximately equal to f, because this is the answer here. Okay? So this is the time we try to, let's recall what we have here. The key part is this part here, actually. Here, this part. This is the key part. We use what? 1 point at x equals 8, the area of the circle will be 25 pi. That's f8. And then we have the other point here on the same graph. That will be what x equals 8 plus h or minus h, either this side or left side. And then the function, the area of the circle will be f 8 plus or minus h. But this one you can think as what? F of x, right? Now, since you have these 2 points, we can find the slope. y2, this is the y2, minus y1 over x2 minus x1. But right now, the approximation with a linear approximation means what? You got to use the slope of the tangent line at this point to substitute the slope of secant line. That's the only approximation. And that will be based on the definition of derivative, based on the concept of derivative with the function, that's the slope of tangent line at that point. So that's why this one. The rest of them, it will be easy, just simplify. Time both sides by x minus 8, and to simplify, we can get up to here. But if we substitute x equals to 8 plus or minus h, put it here, the final answer is here. Okay? Now, we're going to continue with this one. We're going to do what? The c now here, okay? When you do the c, you will see everything's the same, just the function a little bit changed. Just this one a little bit changed. Because they're talking about what? When you do the c there, they ask you if you have a circle. No, not a circle, sphere. If you have a sphere there, and you still have a triangle inscribed inside here, okay, just use different color here. So you still have a triangle inscribed inside here, okay? And just different color here so you can get it easily. So yours is like this. So you're gonna have what? This one just like a make it 3D. Looks like 3D, okay? And then you have a triangle here. And the same thing. This one will be 6. And this one will be what? X equals what? 8 and the plus or minus h. And this is diameter. So when you do this one here, you can get what? The volume of the sphere equals what? The volume, that's a fx, okay? Equals what? 4/3 pi r squared, right? This is the r. This is the r. This is r third power. That's the formula for the sphere. And then we do the similar approximation here. Because this one, r squared, we found it already. R squared and x still the same relation, just like the circle. So r squared is this. So we can find out the fx, the volume of the circle will be 4/3 pi. This one, r squared is that. So our third power will be, because from here you can find what? I just do one more step here first. So you can find r equals what? This r will be equals x squared plus 36 over 4 square root, okay? And then put it here, third power will be what? X squared plus 36 over 4 square root and third power, that's 3.5 power. So when you do the example C here, the question C here, you need to use this objective function to the derivative. But the idea is still the same. Let's continue this one. Let me show you how, okay? Now, I'm going to move up this one first a little bit. The C, okay? The C. When you do the C here, I need to erase something, right? I'm not erase all of them, huh? The C, they say, well, now consider a sphere just to contain a triangle, so that the hypotenuse is the diameter of the sphere. Use the tangent line approximation to estimate the volume of the sphere. So you have this one first, right? And then what are you going to do next? Same thing as what we did. I just, we go like this one here. I erase from here, okay? And get here. So we erase, because we still use this one here. We still use this part. Use the slope of the second line approximately equals the slope of the tangent line. That's the key. And then we time both sides by x minus 8. We got this one. And then we move the f8 on this side, I got this one. And I got to erase this part because after this step, the one you put it here is based on the circle relation, object function. But right now, we got to find we use this one to do derivative there, okay? So that means I erase this part first. Erase this one. And all this is erased. Okay? Yeah, so leave space. So we can do more things there. So let's erase. So, the key concept here is this. We need to use what? We need to use, still here. But right now, the fx is not the area of the circle anymore. It's what? The volume of sphere. Okay? Now, still like this, fx y2 minus f8 y1 over x2, which is x, minus x1, that's 8. And approximately equals what? Derivative of the 8. And then time both sides by x minus 8, you got this one. And then you simplify, got this one. Now, we got to do the derivative now, okay? I put the derivative of this one here. I put it here first, and erase this one first. Give a space to us. So I'm going to the derivative here. Derivative f derivative will be equals what? You have here, you have 4/3, right? You have the pi there, right? And then you got power to 3 over 2, right? And then you have what? X squared plus 36, okay? Plus 36 divided by 4, 3 halves, you minus 1, it will be 1/2. You got it, right? And the chain rule, go inside now. Go inside, this one will be what? 2x. This one is 0, and divided by 4 still there, okay? Now we continue simplify. So we can get what? Here, let me just show you how to simplify faster, okay? 3 cancel, right? This 2 cancel, right? And this 4 cancel, right? So what's left now? Left we have here, we have what? Pi is left. X is left, right? So I put pi x there first, right? And then what's left here? I use different color here, okay? So this is the pi, this is the x left over. And then this part here, you have what? X squared plus 36 half power. It's half power, huh? And then we divide it by what? 2. You get it? Because square root of 4 is 2. And then we can make it simplify. So pi over 2 times by x, and x squared plus 36 and the 1/2 power. So we have fx equals this. Derivative, f derivative equals this now. Now, we plug in this one back to here, okay? So that's why we gotta put what? X equals what? 18 first. So that will be what? F derivative of the 8, right? We need to plug in there. So we will get what? This is the 8 So we have what? Pi over 2 times by 8 times by x, no, this one should be 8, right? So here should be 8 squared, right? And the plus 36 and a half power, like this, huh? So we're gonna simplify this one, okay? We use the calculator. So we do like this here. We do the parentheses there first, okay? 8 squared plus 36, key in there, you got whatever. And the square root, the answer, we got a 10. So this part, this part is 10 right now. And 10, and then you time by the 8 divided by 2, you get 40. So right now we have find out the derivative is 40 pi. Now, we're going to use this one for here, okay? Now we have another one need to find it, which is this part now, F8. F8, we have to use this one here, okay? Because of the volume, huh? So I put it here, okay? So space a little bit limited. So we got this one here, put it here. So we find out this one from here. We find f of the 8, okay? F of the 8, we have 4/3 pi. And then this is 8 squared plus 36 divided by 4, right? And you have what? 3/2 power, right? So we just do the calculation, okay? We can do this way here. We do 8 squared plus 36 equals first, and then we divide it by 4. So we finish the part under the power base here, 25. And then we go power of parenthesis 3/2 power. So we can get what? 125. We got 125 right now. And then we time by 4 divided by 3. So we got a 166.66. We change the fraction as the answer, okay? Fraction equal. We got what? 500/3. So that's why this part we can get what? 500/3 times the pi. Now, we have F8. We have F8 derivative. Plug into here. So we can find out here is what? We can find out is F derivative of the 8. So we put it here easier. Put it here easier. So we can get this one equals to F derivative, which is what? Of the 8 is 40 pi. So we got 40 pi times by x minus 8, okay? And the plus F8 is this one, right? So we put it here. So we got 500/3 pi, right? Now we can simplify further, okay? We continue. Distribute in. So we have what? 40 pi times x and then minus 320. 8 times by 40 is 320. 320 and the pi. And then we add by 500 pi/3. Now, because this one x equals what? 8 plus minus h. So I plug in here right now, this one with what? With 8 plus or minus h. I did not put this one at the beginning because it's easier for me to do the derivative, do the transfer first, okay? So now from here, I can continue now, equals to 40 pi, right? 40 pi. And then time by 8 plus minus h, right? And then minus 320 pi, and still plus 500 pi over 3. Now it's really in. So you get a what? 320 pi plus minus 40 pi, 40 pi h. And then minus 320 pi and plus 500 pi over 3. Now, continue. Continue here, we got what? This to cancel, 320 pi to cancel. So we have what? Positive, negative, 40 pi h, and then plus 500 pi over 3. See here? This is the one we have for the approximation of fx. This is the volume of the sphere. Okay? Now let's go back. What do we have right now? For this one, similar like what we're doing to B, the only difference with this question C with the B is that the objective function here. Because the objective function here right now is the volume of the sphere instead of a circle, okay? So because of this one, you can see this one, we just do the same thing. We do what? You see what we did here? We do this one. See that? Slope of secant line at the point 8, at this point, and this point, same as the slope of tangent line at this point. So let's derive of that. And then you multiply, simplify. The rest of them just simplify. And just simply put what? Put the derivative, this one, see? We put this one here. We found this one, right? For the FA, that's here. And also we find what? Derivative. Derivative, that's this part here, see? We did derivative first. And then we find out the derivative at the x equals 8, we got this one, 40 pi. So we're plugging here at 40 pi. And then the rest of it we just simplify. When we got this one, suppose it's finished here. But we did one more step, plugging positive 8 plus negative plus minus h as the x. When you put it here, you need to get the answer in the form of the h. That's the volume of the sphere. Okay? So if you have any questions, please let me know. Thank you. Bye-bye.